Hi everyone, this is example number 3. I need you to read the question very carefully. Now the diagram shows a solid container that consists of a hemisphere. This is the hemisphere with no overlap that is attached to the end of a circular cylinder of radius r and height h. In other words, if this is overlap, right? If these two solids are overlapped, in other words, this is also going to be r. The total volume of the container is 1215 pi cm cube. Now before we start, okay, I need you to revise what is the volume and total surface area of a sphere. Now you should know that the two formulas are here. If this is of radius r, right, if the sphere is of radius r, the volume is given by 4 over 3 pi r cube, and the surface area is given by 4 pi r square. Now we need to show that h, right, in part 1 is equals to 1215 divided by r square minus 2/3 r. Now how are we going to do that? Now can you find the clue that is inside here, inside the question? Yes, the volume is 1215 pi cm cube. Now, given that, we can actually write that the volume here is given by the two solid. One is the cylinder, pi r square h. The other one is 2 pi r cube divided by 3. How do I get this? This is half of the volume of the sphere. We notice that in this equation, okay, pi appears on both on the left and on the right. So we can actually factorize pi and actually cancel off to get this one. We are going to make this a subject and eventually make h the subject. Okay, let's see part 2. Sorry, I just hit my... Let's see part 2. Okay, we are going to show that surface area of the container is given by this. Now, what shall we do? We notice that the area of the container is given in 3 parts. We can actually divide into 3 parts. One is this base here, which is the shape of a circle. The other one is the curved surface of the cylinder, and the last is the curved surface of the sphere. We can write the surface area to be like that. This is A1, which is the circle. This is the curved surface area of the cylinder, which is 2 pi rh or c times h. And this is the surface area of the hemisphere, the curved surface area of the hemisphere, which is half of the 4 pi r square. We can add these two. And we notice that for here, right, there is a variable h here. And remember that we already found h in terms of r. So we're going to replace this. And slowly we work out. Okay, we are going to expand this. We got this term. We expand this. We multiply this and this. We got this term. And we realize that the first and the third term is actually like terms. We can simplify further to get this. We can actually factorize 5 pi. And we're going to get this. And we rearrange this term like that. And hence we show your A. I'm going to wait for a while for you to digest. Okay, now part 3. Part 3 asks us to calculate, right, the value of R for which A is stationary and show that this value of R found makes A the minimum and find this minimum value of A. There are actually 3 parts in part 3. 3 things that we need to do. First, at the stationary value of A, right? We know that, can I make sure it's right? We know this. Am I right? dA dr must be equals to 0. So we're going to find dA dr and then set to 0. Okay. This is our A. 5 pi is actually a constant multiple. We can bring it out. And we're going to differentiate this term, these two terms here. The first one will be here. Minus 4/6 divided by r squared. And the second one will be 2r over 3. And we set this to 0. And we're going to get this. Now, how do you get this? Okay. 5 pi, I divide both sides. And then 2r over 3 must be equals to 4/6 over r squared. I cross multiply. I'm going to get this. And therefore, r cubed is 729. Maybe I do here. And r will be 9 cm. The cube root of 729. Now, are we going to do the first derivative test or the second derivative test to find or to show that at this r 9 cm, which is stationary, A is minimized? This is the second part of our question. I choose to do by first derivative test. So I have this. I'm finding the gradient, okay, near to 9 on the left and on the right. I put 8.9 and 9.1. Now I'm going to use my calculator. Okay, I'm going to use my calculator to work it out. I'm going to show you, okay. Now this is my dA dr. Okay, 5 pi definitely is going to be positive. So I need to actually work on the value of 8.9 for this. Am I right? So minus 486 divided by 8.9 square plus 2 times 8.9 divided by 3. Okay, I'm going to get negative value here. Okay, again for 9.1 minus 486 over 9.1 square plus 2 times 9.1 divided by 3. I'm going to get positive. So in other words, my second row, right, I will have this. At 8.9 with negative, 9 will be 0, 9.1 will be positive. This is how the shape look like. In other words, at r equal to 9, A is minimized. Now the third part is actually to find this minimum value of A. Now we know that our A is here. We are going to substitute r to be 9 in this formula here. Okay, and we are going to get 405 pi cm cube. For a while, just to show you. Okay, thank you very much.